All right, so we're going to do the same analysis here for part D, okay? So let's rewrite, well, we're going to apply the ratio test first. We first grab AN, like here. So AN is this whole chunk here, and we were looking at the limit of the absolute value of the ratio. So let's just write what it is. So I need AN plus 1, so that means I should look at the product of even numbers, not all the way to 2n. This is the n term in the product. I should also add the n plus first term, so it's 2n plus 2, okay, 2n plus 2. And at the bottom, you have the odd numbers going all the way to 2n minus 1, but this is the n term. I need a n plus 1, so I need to add another odd number, which should be next, right? That's 2n plus 1, okay? And I have x to do 2n plus 1 here, and I'm going to write the flipped version of the bottom, okay? So 1 times 3 times 5 all the way to 2n minus 1, 2 times 4 times 6 times 2n, and x to do 2, this is, by the way, 2n plus 3, right? Because when you write it for n plus 1, it's going to be 2n plus 3. So this one should be 2n plus 1. Okay, you've got to be very careful because you can mess it up easily. And okay, let's put the absolute values back here. Okay, so let's see what cancels out. All right. Well, this product here, the product even numbers starting from 2 all the way to 2n is going to cancel this product here. Okay. And this product here, multiplying the odd numbers all the way, starting from 1 all the way to 2n minus 1 is going to cancel this product here. Okay. So what we're going to be left with, 2n plus 2, x to the 2n plus 3 divided by 2n plus 1, x to the 2n plus 1. Okay, we can simplify this further. Okay, this is 2n plus 2, 2n plus 1 times, you can write the top exponent as like x to the 2n plus 1 times x squared, and x to the 2n plus 1 is canceled out, so you have x squared. I wrote it in a separate form, okay, separate absolute value. Okay, you can also write this as like this. Well, in fact, x squared is positive anyway. But anyway, let's keep it in the absolute value for now. So now I need to worry about this limit. And it can apply to L'Hopital's rule if you want to. And the limit is going to be 2 over 2, which is 1. So here we go. So this total limit is going to be x squared. And I want this to be less than 1. Okay, I want this to be less than 1, right? Okay, so this implies that x is in between negative 1 and 1. Okay. All right, so I got the interval negative 1 and 1. So we got to analyze this at the end points. So let me just write here x equals negative 1 k's, and then let's write here x equals 1 k's. Okay. So what happens if x equals negative 1? Okay, so it's the whole chunk here. Okay. 2, 4, 6, 2n plus 2, and then 1, 3, 5. Sorry, this is 2n. Okay. And 2n minus 1, x to the power of, let's see, x to the power of 2n plus 1, but x equals negative 1. So minus 1 to the power of 2n plus 1. Okay, and for this one, 2, 4, right? Is this correct? Let me just double check. Minus 1, yeah. Okay. 2, 4, 6 all the way to 2n. 1 to the power of 2n plus 1, which is going to be 1, by the way. 1, 3, 5, dot, 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 2, and minus 1. Okay. Well, this is already 1. And minus 1 to the power of 2n plus 1 is just minus 1 because it's an odd power of minus 1. Okay. And in both series, there is no alternation. Right. This is just minus 1 fixed. It's not raised to the power of n or something because we know that the power is odd. No matter what the power is, it's going to be minus 1. So now you can pause the video and start thinking about like what test we can apply for the series. I can tell you that the nth term test would be a good one to start with, or you can compare both series to the series 1 over 2n plus 1. Okay, but I think the nth term test would serve the purpose because if you choose this to be an, and this is the same an anyway, and you can show that, let me just erase this first, okay? You can show that is not equal to 0. Okay? In fact, it should be 1, because the top and the bottom are almost the same numbers, and in terms of the coefficients of n's, they're both 2's for the highest order terms. So this limit should be something around 1, and that is not 0. The nth term test, nth term test implies that divergence here and divergence here. All right. So that's good because I don't need to worry about putting an inequality sign here, right? So now this is the ultimate result. Okay, the interval of convergence is -1, 1. So going back to here, just finishing up this problem, I had to open interval -1 and 1 for this case. All right, this was a long question, but we handled 4 different types of problems. I hope you got the whole idea of handling the power series in terms of finding their interval of convergence. All right, this is the end of it. Thanks for watching. If you have any comments or suggestions, please send those to my way. Bye.